Morning, everyone. Today we're looking at trig functions for any angle, and we're looking at signs of trig functions and using trig values. And this is all for pre-calculus. So let's go ahead and get started with this first topic right here. Trig functions for any angle. Let theta be, in the previous lesson, you found trigonometric functions for positive acute angles. We will now find trig functions for any angle. So let theta be an angle in standard form, and p x comma y be a point on the terminal side of theta. So let this value right here be this right here. It's on the terminal side of theta. Remember, terminal side was the ray that kind of was the last line for the angle, and the initial side was the one that was on the x-axis. All right. The distance p to the origin r can be found using the formula, and this is the formula that we're going to use. X squared plus y squared is equal to r squared. Hopefully that reminds you of the Pythagorean theorem. A squared plus b squared is equal to c squared. There's not much difference. We're just going to be using different sides of the triangle to basically explain the exact same thing. So sine theta, the equation for that, when we're applying it to the trig function to any angle, is going to be y over r. Y over r. The cosine is going to be x over r. Tan is going to be y over x. Your cosecant is going to be, let me grab the marker here. It's just going to be the reciprocal. So we're going to end up with r over y, r over x, and x over y. The reason for that is because r right here is kind of like the hypotenuse. If I look at this triangle right here, regardless of where the triangle ends up, this triangle, what is the longer side? That's always going to be your r, your radius, your hypotenuse. Your y, in this case, is the opposite side. Your x would be your adjacent side. And then tangent is just TOA, opposite over adjacent. So we're not learning anything new. We're just not something completely new. We're just looking at something that is going to be using a different looking formula for the exact same concept. So we've got a point at 9, 12 on the terminal side of theta in standard form. Find the exact values of the trig functions of theta. It's going to be really helpful if when you're working on these, you draw some sort of coordinate so you can figure out where exactly this point is at, and then you can go from there. So it says 9, 12. Let's say it's 3, 6, 9, and then we'll say 3, 6, 9, 12, somewhere around there. Somewhere around here is where I have a point. And the way that I'm going to draw this is I'm going to have a line extending from the origin to this point, and then I'm just going to draw a dotted line just to show you that that's where it's ending up at the 9, negative 12. All right, from here, what is my radius? What is my missing side? I'm going to have to solve for that. That is just your 9 squared, or x squared, remember? X squared plus y squared is equal to your r squared. So 9 squared plus negative 12 squared is equal to r squared. And we end up with 225 is equal to r squared. So my final answer for r is equal to 15. All right, so now we've got all of our values. We've also got x equals 9 and y is equal to negative 12. And then I could just plug in information from here. Sine is y over r. So that's negative 12 over 15. Simplify that. Negative 4 over 5. Find the reciprocal. Negative 5 over 4. Cosine, that is x over r. Think about it this way. Now we have a theta here. That way if it gets confusing, I can say, what's the adjacent side to theta? That's going to be 9 over the hypotenuse, which is, in this case, 15. Simplify that, 3/5. Secant, find the reciprocal, 5/3. Tangent is going to be your opposite over adjacent. The opposite was negative 12, and the adjacent is 9. Simplify that again. -4/3, and then our cotangent, the reciprocal, -3/4. And that's our answers for this work. I'll go ahead and highlight it just to show you my final answer. This one, this one, this one. Okay, so what I want you guys to do is do the exact same thing. Work on number 2 on your own. And then, or if you're with someone in class, work with them. But I'll show you the first setup. We have a triangle that has a point, or we have a point really, that is at -6, -2. So -2, -4, -6, -2. Actually, let me draw this a little bit further down. Okay. So we have a triangle here, or a line here, that extends into the origin. This is at -6, and this is at -2. What you could do, so that it makes a little bit more sense, is move this triangle. So move this triangle over somewhere where you can visualize it a little bit better. Something like that. That's a right triangle. And what is the length of this side? Well, that's just our y value, -2. And then what is the length of this side? Again, that's just our x value, so -6. And we're looking for that inside angle. This one right here. So this one right here. In the purple. How do we find that missing side or hypotenuse? That is just going to be x squared plus y squared is equal to r squared. Hopefully, if you started working on this, the answer should be 2√10. I'm going to end up with 2√10 here. And then I just want you guys to fill it in. Your answers for these should be, I'll go ahead and give you the answers. If you want, pause the video and then wait for me to give the answers, or work on these, then receive the answers. But you should get -√10 over 10, -√10, -3 over √10 over 10, -√10 over 3, 1/3, and 3. So work on those. Make sure that you have any questions. Bring up any questions next time I see you guys in class, if you have any on those. And now let's look at something slightly new. You might have seen this in Algebra 2 or in geometry, but this is going to be the signs of trig functions. So depending on the location of the terminal side of the angle, trigonometric functions can be positive or negative. Using your knowledge of the trig functions values, identify the functions that are positive in each quadrant. So in quadrant 1, we saw that all the values are positive. We saw that last class. All the values are positive. In quadrant 2, if you try to think back and look at your notes, which values did we see being negative? And looking at the values here, I can tell that sine and cosecant are the functions that are positive. So sine and cosecant. Remember that those are reciprocal functions. And then we have which ones are going to be positive in quadrant 3. Those will always be tangent and cotangent. And in quadrant 4, you're going to have cosine and secant. Cosine and secant. That one I can kind of use the example from here. Which ones were positive? Cosine and secant. As we can see here, cosine and secant. Everything else was negative. These two were negative. And if I use quadrant 3, I could see the answers here as well. Which ones were positive? Tan and cotangent. All right, let's go back to this one. So that's where I'm getting this information. All right, and I might even go ahead and label this. So Q1 is just all of them can be positive. In Q2, you have sine and cosecant. Q3, you've got tan and cotangent. And then in Q4, you've got cosine and secant. So remember the phrase, all students take calculus? All students, think about it this way, all students take calculus. And then if you want to remember which other functions fit in there? Well, it's just going to be the reciprocal function. All right, so if cosine theta is greater than 0, which quadrants could the terminal side of theta lie in? So if cosine theta, let me write this down. If cosine theta is greater than 0, meaning it's positive, where could the terminal side of theta be? That could be in either, if it's positive, it can be in either 4. So I'm going to write it down, quadrant 4, and the only one that includes everything, quadrant 1. If sine is less than 0 and cotangent is greater than 0, which quadrant could the terminal side of theta lie in? So I'm looking at number 6. If sine of theta is less than 0, meaning it's negative, and cotangent is greater than 0, so we have to look for something that makes this positive, but then we'll have sine being negative. The only time that tangent is positive, and thus implying that everything else is negative, is in quadrant 3 from what I can tell. Because if I said, when is cotangent positive, then I could say these two right here, quadrant 1 and quadrant 3. But I'm saying, when is this one positive and sine is negative? So here, and it's going to be negative everywhere else for sine. So only in quadrant 3. Okay, I want you guys to do 4 and 5. If you pause the video, you can try to work on those. I'll go ahead and give you the answers now. It's quadrant 2 and quadrant 5. Over here, quadrant 2 and quadrant 3. All right. Again, make sure that you save any questions for when I next see you guys in class. We're going to use all this information to try to figure out the trig values and find other values of these triangles. Let's see. Sine theta is equal to 8 over 17, but tan theta is greater than 0. When is tangent theta? Oh, less than 0. Less than 0. Tangent theta is negative. It's negative in... okay. So this is kind of a tricky question. What do we know? We know that sine is positive, and we're saying that tangent is negative. So when is tangent going to be negative? Well, we're saying tangent is negative. We know that it's positive here, but we know that it's negative here, and it's a negative here. But it's also positive here. So we don't want to have this involved because it says it has to be negative. Can't have quadrant 1. And we obviously can't have quadrant 3. And then, so these are out. And then it's saying, when is sine positive? If these two quadrants are already out, the only time that sine is positive is in quadrant 2. So we're looking at quadrant 2. And this will help us understand what exactly we're looking for in a second. Since we're in quadrant 2, we're going to make our triangle facing this way. Whoops. Not at all what I wanted. Okay, here we go. Sine of theta. Put theta down here in the corner, because you're going to imagine that this is all on an x-axis. Whoops. Yeah, we're going to try to imagine that this is on an x-axis. And now, hopefully it makes a little bit more sense when we apply the previous part. Sine theta opposite, 8 over hypotenuse, 17. What is our x value going to be? Once you do x squared plus b squared equals r squared, whoops, sorry, or really I should say a squared plus b squared is equal to c squared. That way it doesn't confuse you guys. Our a squared is 8 squared plus b squared is equal to 17 squared. So b squared is equal to 225. Again, we saw that in the last problem. B is equal to 15. In this case, it's a negative 15 because we're in quadrant 2. And remember, if we draw the x-axis and the y-axis, that x is extending into the negative. All right, so now we just go ahead and plug in everything that we know. Cosine theta, adjacent over hypotenuse, so negative 15 over 17. Tan theta, opposite over adjacent. So that's 8 over negative 15. Cosecant, that is just going to be 17 over 8, because that's the hypotenuse over the opposite. Secant is negative 17 over 15. And then lastly, cotangent is just the reciprocal, so negative 15 over 8. I know it's kind of tricky. Another way that you could have solved this is you could have said, you could have told yourself, I'm going to find all the sides of the triangles, and then I'm going to plug in, let's say, you're going to plug in your fractions. So you'd have 15 over 17, 8 over 15, 17 over 8, 17 over 15, and 15 over 8. And then you could have gone back and said, what values are positive in this type of triangle when you're looking at quadrant 1? The only ones that are positive are sine and cosecant, meaning that this is the only one that stays positive, and then you would have to go back and just plug in a negative everywhere else. That's a different way of doing that. Oops. All right, last one. I would want you guys to work on number 9. I'll give you guys a couple clues. It's saying cosecant is negative, and also cosine is going to be negative because it's less than 0. When is cosecant negative, and when is cosine negative? Cosecant is negative, let's see, everywhere else except for quadrant 4, and cosine is negative. Where is it? Oh, sorry, I'm the wrong one. Cosine is negative, everything except for quadrant 4, and it's also going to be positive in quadrant 1, so we have to get rid of that. When is cosecant negative? Not in quadrant 2, because that's when it's positive, so we're left with quadrant 3. Quadrant 3. Again, you don't have to do it this way. You could just go ahead and try to solve for the sides and go from there. You could have just said, let me draw a triangle, make this my theta, this is 2, this is root 5, therefore this is 1. You could have said that if you wanted. Or you could have said, if it's in quadrant 3, then I know that it's going to look more like this. Because one of the legs is on the x-axis. Oops. Thus your right triangle is here. Your theta would be here. And if that's theta, then this is 2. This is root 5. And that's 1. You can't have... And then you'd ask yourself, where does the negative go? This negative? You can't make this negative because that's the distance of the hypotenuse, of your radius. So, which one is actually negative? It's your 2, your y value. And then you could say x squared plus y squared is equal to r squared. You knew half of that information, and we would find out that x is equal to 1. That's where I got this 1 from. And that's pretty much it. I want you guys to solve number 9. I'll go ahead and write the answers here. That way you can double check. The answers are negative 2 root 5 over 5. Negative root 5 over 5. 2, 1/2 down here, and negative root 5. And this all makes sense because if we're in quadrant 3, what's the only trig function that can be positive? Tangent and cotangent, which means that everything else should be, should be negative. So tangent and cotangent are the only positive ones. We'll go ahead and stop here for today. Your homework will be not this right here. So homework 6, questions 1, 2, 3, and 4. Yeah, 1, 2, 3, and 4.